Traditionally, launching a new product is a time-consuming and complex project. Why is it so difficult? With Symphonica, it's easy. Our service orchestration engine is ready to serve with pre-configured workflows and pre-built endpoint integrations that securely facilitate a faster and simpler service launch. In addition, Symphonica provides a codeless design studio that enables a quick and easy configuration and deployment of new orchestration and automation processes. No coding needed, and no risky software upgrades required. With Symphonica, you can decrease deployment and service launch times, reduce deployment and maintenance costs, and you don't have to worry about system administration, software upgrades, and platform availability and scalability. You can rest assured your network elements and customer data is protected with secure links and VPN tunnels. Let's see how a small cell deployment use case was resolved using Symfonica's Design Studio. This is a high-level architecture diagram of Symphonica for infrastructure management. It has three main modules: a mobile application for technicians to do bottom-up provisioning of small cells, automating the installation, and generating certificates; an infrastructure manager that is a design time cell planning tool; and Symphonica, that integrates with the different network elements using multiple protocols to fully automate the deployment of the small cell. In the demo we are going to see next, Symphonica will receive a small cell deployment order from an external cell planning tool. The installation is going to be completed in the field by a technician, using Symfonica's Tech Assist app. First, we are going to send an order to Symphonica to deploy a small cell, including a co-located broadband device. In this case, a GPON optical network terminal, an ONT, to connect it to the backhaul. This order is sent from a cell planning tool to the Symphonica orchestration engine. So, let's send the order. Okay, the order has been sent. And now, as we refresh the listing, we see it on the console. Now, let's dig into the details of the order. We can see that the order includes the provisioning of broadband access for the connection to the backhaul and a small cell. On the day of the installation, a technician will be dispatched to the field to physically connect the ONT and the small cell, and then finish the installation process using Symfonica's Tech Assist app in his phone or tablet. Let's do that. I'm mirroring the phone on the left of the screen, and we are seeing Symphonica Tech Assist app. If I go to Tasks, we can see that we have a task to complete the ONT installation, which is the broadband co-located device, to give the cell access to the backhaul. Before completing the task on the right of the screen, I will open the access installation workflow in Symphonica, so we can see what is happening behind the scenes when the technician triggers the access installation. Here, we see that the workflow is waiting for the ONT serial number. On the phone, I will claim the task, scan the ONT serial number, and hit complete task. Now, we see on the right how the provisioning workflow continues and finishes the access installation. As part of the process, we can see that the port on the OLT is configured, also the radius server, and finally, a quality test and installation certificate are generated. We can see on the phone that the access installation is completed, and the test results for the ONT power levels are all good. Next, we will go back to the tasks. Now, we see there is a new task to install the small cell. If we go again to the order in the Symphonica console and refresh it, we notice that the provisioning of the access is completed, and now the installation of the small cell is in progress. Let's go and validate what that workflow looks like behind the scenes. Here we see that the workflow is waiting for the home eNode B identifier. I will complete the task now, scanning the home eNode B cell identifier on the phone. Now, the provisioning workflow continues and finishes the small cell installation. As part of the process, the flow shows that the security gateway is configured. Here we can even visualize the CLI commands sent. Also, the home eNode The gateway is configured. Here we can see the cell identifier we just scanned is declared, and the cell configuration parameters sent to the home, eNode B, management system. Finally, a quality test and certificate. On the phone, the technician is able to confirm that the small cell installation is completed, and the test results for the small cell are all good. The test displays technical values such as the band and frequency the cell is operating on, the mobile network code and country code values, and also the levels for SNR, signal-to-noise ratio, RSRQ, reference signals received quality, and RSRP, reference signal received power. With these two simple steps, the small cell is up and running, with installation quality assured. As a summary, we installed the small cell, and the access to the backhaul, with a co-located broadband device, in a fully automated way. The technician finished the installation with a mobile application, in less than 5 minutes. Symphonica orchestrated this complex process, integrating with multiple network elements, using different protocols like HTTP and CLI. Thanks for watching our demo video. You can request a demo, or access more resources, at www.intraway.com/dtw2020.